Hello everyone, let's discuss another test of transformer, that is short circuit test. So last class we have discussed that open circuit test. So by conducting that open circuit test we are going to get iron losses, right? In addition with the iron losses we are going to get shunt branch parameters, that is R0 and X0. So the main objective of this short circuit test are to find out the variable losses, right? So we are going to get constant losses from OC test. Like that, we have to get the variable losses by using short circuit test in a transformer. So variable losses are nothing but what? Copper losses, right? Copper losses are nothing but variable losses. So by using this test, we are going to get the copper losses, and we have to find out the series branch parameters in ohmic values when referred to the winding in which the test is going to conduct. That is, we have to calculate R01 and X01, like that, R02 and X02. These are nothing but what? Series branch parameters, right? So these are the series branch parameters. When they are referred to primary, what is the series branch resistance? R01 should be equals to R1 plus R2 dash, right, which is equals to what? R1 plus R2 by K square. Similarly, X01 should be equals to what? X1 plus X2 dash, which is equals to X1 plus X2 by K square. Similarly, if referred to secondary, if it is referred to secondary, that is R02 should be equals to what? R2 plus R1 dash, which is equals to R2 plus K into R1. Sorry, K square into R1. Similarly, for X02, this is X2 plus X2 dash, which is equals to X2 plus X1 into K square. So like that, when this test is going to conduct on either side, so these are the series branch parameters with respect to resistance and reactance. We are going to get variable losses and these series branch resistances and reactances. So the equivalent circuit of a transformer when referred to primary side, if I0 is very less, then what will happen? Neglect shunt branch, right? If I0 magnitude is very less, then neglect the shunt branch. Therefore, the circuit becomes what? We have R1 and X1. Simply we have R2 dash, X2 dash, and this is secondary. What about secondary? Secondary is what? Short circuited, right? This is the supply voltage. From this we have R1 dash, X1 dash, and then R2, X2. When it is referred to primary and secondary, so this is the supply voltage. When it is referred to secondary, this is what? KV1, right? So we all know that this is what? R1, X1. This is R2 dash, X2 dash. This is what? R1 dash, X1 dash, R2, X2. So these are nothing but what? These are nothing but the circuit should be like this. ISC, this is the supply voltage. Like that, the circuit becomes this is what? KV1, right? Now what is this resistive branch? R01, right? This is R01 series branch resistance and reactance. Like that, this is what R02 X02. Now we are going to get the series branch parameters referred to primary, series branch parameters referred to secondary. By using this test, we are going to calculate R01 X01 or R02 X02. So in short circuit test, but in case of open circuit test, we are going to conduct open circuit test at V rated and F rated. But in case of short circuit test, the applied voltage at rated frequency should be gradually increased until rated current passes through both the windings. So OC test should be V rated and F rated. But coming to SC test, it should be conducted at I rated. This test is going to conduct at I rated. This test is going to conduct at V rated. What is the reason? Because in open circuit test, the losses, iron losses are purely dependent on voltage. But in case of short circuit test, we are going to get copper losses. Those are nothing but purely dependent on current. That's why OC test is due to V rated and F rated. Those are nothing but iron losses. These are nothing but what? Copper losses. What is the reason? Copper losses are dependent on current, and iron loss are dependent on voltage. That is the reason. So, but in case of short circuit test, we have to increase the supply voltage till we are going to get the rated current. Till we are going to get the rated current, we have to increase the supply voltage. So in short circuit test, the rated current is to be allowed. The rated current is to be allowed in the winding without wasting of output power. So what is meant by steady short circuit current? So this is an amount of current that will flow through transformer windings under short circuit condition corresponding to rated applied voltage. Then what is rated short circuit current? Rated short circuit current is the rated current in the winding under short circuit condition corresponding to reduced applied voltage. So we have to provide rated short circuit current by increasing the supply voltage. So generally the voltmeter indicates the reduced applied voltage to get rated current and short circuit voltage. So ammeter indicates rated short circuit current ISC. Wattmeter indicates the power loss. The power loss is nothing but what? Copper losses, right? And how much amount of supply voltage that we have to provide? That is 5 to 8% of supply voltage is needed to get rated short circuit current in the winding. Only 5% of rated voltage is required to get rated current in the transformer. So this is the circuit arrangement. This is a single phase supply, rated frequency with I rated. Okay. Across we are going to connect a voltmeter to calculate the supply voltage, that is 5% of V rated, right? 5 to 8%. This is the calculation of ISC. We are going to calculate the rated current by varying the supply voltage, and this is the wattmeter. So this is the wattmeter which shows what? Copper losses. And we are going to conduct this test on preferably on HV winding, and LV is what? Short circuited. This LV is what? Short circuited. We are going to conduct preferably on HV winding and LV short circuited. As rated current is less on HV side, it is more convenient to conduct this test on HV side by short circuiting LV terminals. By doing so, low range meters can be used for conducting this test. So on HV side, I rated is very small. That's why it is very convenient to conduct test on HV side. Is there any change in the copper losses if we are going to conduct this test on LV side? For example, SC test is going to conduct on HV side, LV short circuited. and the amount of copper loss are 100 watts, and the same test can be conducted on LV side but HV short circuited. There is no change in the copper loss. PCU should be equals to PCU, which is equals to 100 watts only. Either HV or LV, the same amount of copper loss should be obtained, but the more convenient side is nothing but HV only. The more convenient side to conduct SC test is on HV side, LV short circuited. Then how we are going to get the very small amount of current on HV side? For that, I would like to consider one example. Very small amount of current is needed to conduct. That is, see, as we know that the voltage required for short circuit test is 5% of rated voltage. So these are the nameplate details of rating, and these are the nameplate details of a transformer. For example, if the test is on HV side, LV is open. So in that case, the applied voltage is what? 5% of rated voltage, that is I rated on HV, right, which is equals to KVA rating, right, KVA rating by HV is nothing but what? E2, right, which is equals to KVA is what? 200 into 10 cube by 2200. So 200 by 2200. So first we have to calculate the voltage. First we have to calculate the voltage. Later we have to calculate I rated. So in order to calculate I rated, 5% of supply voltage is required, right? Therefore, V voltage equals to 5 by 100 into 2200, right, on HV. What is the answer? 110 volts. So 110 volts is required to set up rated current. 110 volts is required. Out of 2200, 110 volts is required to set up rated current. That is, 110 volts is required to get I rated, right, on HV only. Keeping, sorry, LV is short circuited. This is short circuited, not open. Sorry, there are so many changes. If the test is on HV side, LV is short circuited. If the test is on, kindly make the changes, LV side, this is HV. HV is short circuited. Okay. If the test is on HV side, LV short circuited. If the test is on LV side, HV short circuited. So if it is on HV side, this is the voltage which is required to set up rated current. Then what is the value of I rated? Therefore, I rated on HV, right, which is equals to, what is the voltage? I rated on HV is nothing but 20 kVA, that is 200 kVA into 10 cube by, what is the HV voltage? 2200. What is the value? You will get 91 amperes. Okay. This is the rated current. When we provide, that is, if 110 volts is provided, that is, okay, that is 110 volts is provided to get the rated current of 91 amperes. Okay, this is when the test is on HV and LV is shorted. This is on HV LV shorted. This test is on HV, LV shorted. Now, what will happen if we are going to conduct this test on LV side? HV is short circuited. Then again 5% of rated voltage is required to conduct this test. Therefore, supply voltage need to conduct this test. That is 5% of, what is the voltage here? LV 220, right? Then what is the answer? 11 volts is required. Okay, 11 volt is required, and the current is what? I rated LV, right? And the current I rated LV is nothing but what? VA rating of transformer, that is 200 into 10 cube by what is the EMF 220. So in this case we are going to get 910 amperes. Is it less value or more value? So 91 amperes is very less compared to 910 amperes. That is 11 volts is required to get 910 amperes. This is what? Rated, right? So 11 volts is required to get rated current of 910 amperes. So this is the condition when this test is on LV side, HV is short circuited. So just compare this case 1 and case 2. Which one is more convenient to conduct this test? The case 1 is more convenient. Why? We are going to get 91 amperes only. So for this, thus we see that the measurements were made on low voltage side. The voltage needed to be inconveniently low, that is 11 volts only, but the current would be inconveniently high, that is 910 amperes, approximately 1 kilo ampere, that is approximately 1 kilo ampere. This is not impossible to get the precision range meters. That's why with the amount of 110 volts we are going to get the rated current. This is enough to conduct the SC test. But if we are going to conduct this test on LV side, obviously the rated current required is very more compared to HV side. That's why this test is preferably on HV side, LV is short circuited. But what about open circuited? The test is going to perform on LV side, HV side is open. Like that you have to differentiate open circuit test and short circuit test. So what are the main objective of this test? We have to get the variable losses. So the wattmeter readings are nothing but what? Copper losses only. But small amount of only 5 to 8% of rated voltage is required to get the rated current. But small amount of iron loss are present. Those are neglected in this test. That's why the wattmeter reading shows what? Full load copper losses only. Next, what are the second objective? We have to calculate the series branch parameters. Series branch parameters, right? R01 or X01, R02, X02. So these are the wattmeter readings. So we all know that copper losses PCU, which is equals to what? ISC square R01. Or you can say ISC square R02. Whatever it may be with respect to R01, here the readings are like this. So from this, R01 should be equals to what? Wattmeter readings by rated current whole square, then only you are going to get R01 completed. So this is the equivalent circuit of a transformer under short circuit test. So that is primary R01, X01, the current through this is nothing but ISC, and this is what? Short circuited, right? As 5% of voltage is required to get the test, that is I0 is very small and it is neglected, hence no load branch is neglected in the equivalent circuit under short circuit condition. So what is the VSC? This is nothing but ISC into R01 plus J into X01 from this. So from this ISC gets common, R01 plus J X01. So VSC is, this is nothing but what? Impedance Z01. So from this Z01 is nothing but what? Short circuit voltage by ISC. So we all know that R01 is there, X01 is there. So from this we are going to get X01. Similarly, for do the calculations for R02 and X02, you will get the same values. Okay, this is about the short circuit test. For example, this test is going to conduct at a rated short circuit voltage but less than rated frequency. What are the changes in the copper losses? We all know that R01 is nothing but constant because it is independent of frequency. Clear? What about reactance? Because reactance is nothing but what? 2 pi f. If frequency increases, obviously reactance increases. If it is decreases, reactance. If it is decreases, this is decreases. So frequency decreases, reactance decreases. So what about the resultant impedance? Obviously decreases. There is no change in the resistance, but coming to frequency changes, reactance decreases. Ultimately, Z01 should be equals to what? R01 whole square plus X01 whole square. This is decreases. Obviously, this impedance is also decreases. What about short circuit current? Short circuit voltage by impedance. This is constant. So obviously, this is decreases. This is increases. ISC increases. What about copper losses? These are nothing but copper losses are also increases because care of the current. Like that, short circuit power factor is also increases because impedance is decreases. Short circuit power factor is increases. So like that, we are going to get the different cases. Then for you, the homework is what? Do the analysis for Vs equals to constant and F is more than F rated. What about cos phi SC? Is it decreases or increases? So if F less than F rated, it is increases, but here F more than F rated, obviously this is decreases. Do the analysis. So this is about short circuit test.